Good afternoon, everyone. Thank you for your patience, and I do apologize for the slight delay in start. My name is Alexandra Papaikonomou, and I just want to make sure, Jay, you're on the phone?
I am, Alex.
You are great. Perfect. We're going to run through a few logistic items before the webinar starts. Your lines will be muted. There might be some background noise, but I'll try to mitigate that manually. But if you have any questions, please type them in the chat section as we go, and they will be answered at the very end of the presentation. If you come across any issues throughout the webinar, please send a direct message to myself, TRCA host, within the chat section. So let's begin. On behalf of Partners of Project Green and our webinar partners, Greening Greater Toronto, Better Buildings Partnership, Canada Green Building Council, Greater Toronto Chapter, and Hydro One Brampton, I'd like to welcome you to our monthly series of Green Technology webinars. Partners in Project Green is a growing community of businesses working together to green their bottom line by creating an internationally recognized eco-business zone around the Toronto-Pearson area, which will be known for its competitive, high-performance, and eco-friendly business climate. Through these monthly webinars, we hope to bring the latest technologies and tools to the comfort of your office and provide a format to ask questions that will help you discover the right solutions for your operations. Partners of Project Green offers many resources, and I encourage you to visit our website at partnersofprojectgreen.com just to see our programs, our training, and events that are coming. So this afternoon, we are exploring energy management and sustainability, which is always an exciting topic. We're very fortunate to have Jay Zollner from Ameresco calling in from South California this afternoon to lead the discussion. Mr. Zollner is the Executive Vice President of Ameresco Intelligent Systems. He has over 30 years of management experience in the energy and energy efficiency fields. He founded a startup company, now AIS, that successfully developed and commercialized Exchange Point, one of the first real-time software as a service sustainability platforms for the enterprise, which earned the company recognition as a global clean tech 100 company in 2009. Mr. Zollner served as an invited panel member for the California Public Utilities Commission's Forum on Diversifying California's Green Economy, discussing the impact of California's AB 32 climate change legislation. He often speaks at industry and trade conferences on energy and efficiency and sustainability. Mr. Zollner has a bachelor's degree in physics and served as an officer in the U.S. Navy submarine service. So Jay, if you can take it on now, that would be great.
Welcome everyone, and thank you for participating in today's webinar that's sponsored by the GTAA's Eco Business Zone program. I'd especially like to thank you, Alexandra, and your team from GTAA for your support in organizing and setting up this webinar through the Partners in Project Green program. As Alexandra kindly introduced, my name is Jay Zollner, and I'll be your presenter for this webinar. As she mentioned, I am the Executive Vice President for Ameresco's Intelligent Systems Business Unit, and I've been in the industry for the past 30 years with experience that includes power generation development, implementation and operation, utility transmission and distribution system engineering, design and project implementation, and for the past 15 years, energy efficiency and demand response management. The last 5 years, as she mentioned, was specifically spent developing software technology to deliver enterprise energy management. So I'm very pleased for this opportunity to discuss the key elements that Ameresco has experienced that are important to successful enterprise energy management. Before we dig into the presentation today, I'd like to provide a brief description of Ameresco so that you have an understanding of our company. We have a very strong presence in Canada as well as in the United States, and our Canadian presence includes 10 offices in 5 provinces and nearly 150 people that provide energy efficiency, renewable energy, and consulting and project implementation services. Our largest office is located in the Toronto area in North York and is also the headquarters location for Ameresco Canada. Ameresco's clients are in all sectors of the economy, including provincial government entities, universities, and cities. However, today I will be addressing my comments toward the commercial and industrial client base, since that's the primary focus of this webinar series. If there are questions about the public aspects of our business, I can certainly point you to the appropriate contact during the Q&A period. So quickly, Ameresco is a public company registered on the New York Stock Exchange. It is one of the largest independent energy services companies with revenues that are north of $700 million annually. We're technology and equipment agnostic, and we deliver both energy efficiency and renewable energy services. We've delivered more than $5 billion in energy solutions that have been delivered, and we've sourced and raised more than $1.5 billion in project finance, and we have a strong bonding capacity. As I mentioned earlier, we have over 900 employees throughout North America with 63 offices that are located in the 5 provinces in 34 states. We also have a few international locations, but primarily we're concerned here with North America and Canada. As you can see, these are a few representative customers that we have in Avon, personal care products, food processing companies, well-known craft foods, and BMW, auto manufacturing companies. And we have a plethora of companies and associations that we're members of and qualified to participate in. One important note is that the Exchange Point solution that we'll talk about a little bit later is a Carbon Disclosure Project certified accredited provider for the carbon calculations that are represented there. So with that background on Ameresco, let's move to the next slide to set the table for our discussion today by understanding what successful organizations practice in the area of energy management. So a renowned market research firm, the Aberdeen Group, performed a market survey of companies to determine whether a correlation existed between a company's performance to their corporate operating plan and how they manage their energy use. The results are summarized in this table. As you can see, they concluded that there is a very bright line between the best-in-class companies and those that still struggle with energy management. As you move from left to right, the class category, best-in-class, industry average, or industry laggards, is basically defined by whether they are in the top 20%, the middle 50%, or the bottom 30%. But clearly, in the performance end of things is where you begin to see the differences according to the Aberdeen Group and their survey that they reported on energy intelligence. The best-in-class companies basically performed 14% better on their operating margin versus their corporate plan. And corresponding, they had a 15% reduction in their production-adjusted energy use. Industry average companies, basically which comprise the middle 50%, enjoyed a 2% operating margin relative to their corporate plan, and a 7% reduction in their production-adjusted energy use. The laggards, which comprise the bottom 30%, basically were underperforming their operating margin plan by 9% and actually experienced a 6% increase in their production-adjusted energy use. This research presents a very compelling picture for those companies who aspire to be known as best in class when it comes to their operating financial results. One thing that a best-in-class company needs to practice well, apparently, is the effective use of their energy. The research goes on in the details of it to show that the most prevalent energy management strategy that's more likely to be employed by the best-in-class companies versus the others is to optimize their production processes to be more energy efficient. But what does this mean specifically? It means that the best-in-class companies are using actual energy consumption at the unit level to make real-time decisions for optimizing their production, maintenance, and energy delivery decisions. In other words, energy optimization decisions are not focused by tracking energy consumption at the utility bill level alone, but where they can have a demonstrable impact on performance. That requires intelligent operational decision-making. Your LDC understands this correlation, and they have a very effective program to help subsidize the costs of accessing this critical unit level energy information. It's called the Monitoring and Tracking Program for Energy Efficiency. Now, of course, all this energy unit level information is just data unless it's processed within the context of a structured program. So let's move to the next slide and discuss what the International Standards Organization has to say about how that might be structured. What's striking about the International Standards 50001 is the simplicity of its design, the flexibility of its guidelines when you get into the details, and the emphasis on continual improvement. Most organizations, the best in class, average, and the laggards, are likely to have some pieces of the standard in place already. Whether they know it's associated with the standard or not, they're probably doing some portion of what you see represented here. But as an example, how many organizations today do not have a sustainability policy and its attendant goals? This first block up here in energy policy. If they don't, they're very likely to be the smaller organizations. But even so, the research indicates that these smaller organizations should practice sound energy management if they are to aspire to be a best-in-class organization. But we've all heard the saying, the genius is in the execution. Implementing these guidelines that are recommended in this standard and executing its recommended practices, especially within a larger organization that has distributed facilities, offices, and operations across the provinces, North America, or the world, is an altogether different challenge. But it can be done cost effectively with technology, and global organizations are doing it today. The international standard provides the framework for an organization's energy management program. If you've read the standard, you will realize that one thing is central to its framework, and that is documentation. I'd like you to keep that point in mind as we move through this slide and the remainder of this webinar. But what's key about it is that there's an energy policy.
They never have done this before? I mean, staying.
Excuse me, sorry, I believe I hear a lady who is talking.
Oh.
Excuse me, hello?
Well,
Hi,
yeah.
is it Helen?
In their country, there could be the similar thing.
I'm not able to
but
mute
they
anyone
never
who's
have done
not muted already. So just, I apologize for the interruption here. I believe there's a few people, Helen and Dave, I'm not able to mute you. And if you could just make sure that your phone has been muted. And also Tasha Huang, if you could just make sure that your phones are muted, that would be greatly appreciated.
Thank you, Alexandra. I appreciate that. So one of the things that's key about the International Standard 50001 is the fact that it has to, it requires the energy policy, energy planning, implementation, and operation, but it's also central to it is the checking component of what you're doing relative to the implementation of an energy management program. And what's critical is the fact that it is a continual improvement program, a continual improvement process. So in other words, there's always standards where always implementation and processes and things that need to be done to check and verify the success and the effectiveness of the energy management program. So one of the elements of enterprise energy management best practices is to make sure that you have a model for how you're going to implement it, and it should incorporate these key things. So 5 key questions to ask of your organization are the following. Does your organization have an energy policy? What is the organization's energy plan that supports the policy? Can you easily assess your progress against that plan for a particular facility and or for the enterprise as a whole? 4th, does your organization have structure for the implementation of the energy plan that includes checking, a verification process? And then finally, how easily can your organization translate successes in one location that may be happening across the entire enterprise? Those 5 key questions are things that you might want to ask of your organization to make sure that you're appropriately implementing the right structure. I'll provide examples of our experiences with companies who are implementing enterprise energy management programs and discuss Ameresco's perspective on the elements to successful enterprise energy management. But let's first get back to some important research that was recently completed about why organizations are not becoming energy efficient and sustainable more quickly. What's central to whether you have an energy policy, whether you have an energy plan, is be able to address all the reasons that impede success for why they're not becoming more sustainable and energy efficient. We all know that the Pew Center is a globally recognized research firm. They issued their Global Climate Change Report in April of 2010. This report condensed the results of a survey which asked 65 key questions of nearly 100 companies about their energy management and sustainability practices. Now please note that the report is very comprehensive and goes into much deeper detail than I plan to here, but there is a consistent theme to the reasons why companies responded that they were not being more successful with their progress towards sustainability and energy efficiency. And those reasons go beyond simply identifying the need for a defined energy management program like International Standard 50001. They can be generally classified into the following 4 reasons. First, as you can see here, are the organizational disconnects. There's a lack of real-time information that's available to the entire organization, and that lack of information dilutes the translation of vision into action. In other words, the energy policy that's established at the beginning that many companies have difficulty getting translated into action because they have a hard time accessing real-time information that's related to what they're doing and getting that information distributed to the entire organization. Secondly, the actionable information that they do have is scarce. In other words, there's weak interpretation of the data. The data may be low quality and or old, that's unrelated to the purpose of the organization. And all of those uncertainties basically legitimizes delays in any decision-making about progress that they can make for sustainability and energy efficiency. Third, there is limited energy expertise and sustainability expertise. So in other words, time spent by client personnel to identify, develop, and implement solutions distracts from their key responsibilities. And without the expertise, it's an ad hoc solution, an ad hoc approach. And so as a result, other capital needs always get the priority. So the uncertainty about whether the results in these first 3 reasons about whether the energy savings, the water, or the emissions reductions will persist over time, and the lack of data to support it, especially related to the primary business, reinforces the bias toward other capital deployment, even when the profit impact across the enterprise from those savings may be large. So the elements to a successful enterprise energy management program are becoming a bit more clear. First, the aspirational goals of whether to be best in class is critical. If you do wish to be identified as best in class, then there needs to be a structure for how to get there. And that structure needs to be able to address the key reasons which prevent its progress. International Standard 50001 is certainly an excellent model and a great standard for that. But organizations, as we all know, always have the tendency to want to make immediate progress once a problem is identified. An example would be to perform an audit to identify the energy efficiency projects that can be implemented right away, get the savings so that progress can be demonstrated. That approach does provide some short-term gains. But let's take a look at what the experience shows the real results might actually look like over the long term. Typical energy and sustainability policies go something like this, if you're familiar with it. 20-20-20 by 2020 might be an example. where each 20 represents the percent reduction in energy, water, and carbon emissions that are to be reached by the year 2020. That sounds about right, I think. The numbers may vary from organization to organization, but the idea is generally the same. These policies are an important vision statement and a necessary step to establish the goals to achieve, but in the International Standards 50001 lexicon, it is only the first step, the energy policy box. When asked about methods to achieve the plan, most organizations have difficulty verbalizing the philosophy about how to reach those goals, much less the means and the methods and checking protocols that the international standard advocates. So the above picture represents the typical results that can be expected versus an established philosophy of, say, maximizing return on invested capital through a control, replace, and shift philosophy. That's just one philosophy that an organization could adopt. Let's control, replace, and then shift. Another example might be, let's use energy savings and finance those energy savings to make improvements to our overall infrastructure. Whichever course or whichever philosophy that needs to be adopted or that is adopted by an organization, it needs to be clear about how they plan to reach their goal. So let's talk a little bit about what this particular example shows with a typical approach versus maybe what a best practice result is when you have a particular philosophy to achieving your goals. In the usual effect where I demonstrated a need is identified on this blue line, this blue line represents, let me just give you the axes first. The vertical axis is the energy cost per unit of production, and the x-axis is time. And what typically happens is energy costs per unit of production begin to rise, and so somebody eventually takes notice and says, like I initiated before, there needs to be some action taken, so let's do an audit and then do the projects that are associated with that. And as a result, you get this decline in the energy cost per unit of production over time. But without an overall structure like the International Standard 50001 advocates, what happens over time is that pretty soon attention wanes, there's no real process to check, verify, and monitor, there's no management review, and as a result, costs begin to go back up over time. And then again, at some point out in time out here, oops, we're basically back to where we were before, and so the cycle repeats itself.
Online training made easy. There are 26 other callers on the call.
Hi, everyone. Sorry, if we could just maybe mute your speakers, that would be great. I was just sending a message for everyone. We are having a few issues with muting some people, so if you could just be very cognizant of the sound that you're creating, and I really do appreciate your participation and your patience in this matter. Thank you so much.
And so as a result, there's no real progress over time that's made in reducing the energy cost per unit of production. However, in this particular example, the client basically implemented a control, replace, and then shift. So control being, let's control the energy use and modify behavior first. Then let's consider replacing, identifying, repairing any energy issues that happen. And then let's consider shifting to a, say, a combined heat and power or waste to energy production or something like that. And with that, there's a more dramatic decrease in the energy savings and a more sustained approach over time. And then as you implement that control replace structure with a process like International Standards 50001 advocates, and in our case technology, then you begin to get a sense for the fact that you can sustain the savings over time. Industry average results basically would get you this type of, if you refer back to our best-in-class industry average or industry laggards performance. So Ameresco advocates that if you're interested in the highest return on invested capital, then you would control, replace, and then shift. That philosophy helps you structure, implement, document, and communicate your plan to achieve continual success. One of the ways that you can do that is through monitoring and targeting of specific end-use processes like the Aberdeen report and the Pew Center report was advocating. So that basically is this overall process where you're monitoring specific plant instrumentation. You pull that information into a PLC. You aggregate that with information from power meters and water meters and utility flow meters. You aggregate that into any existing plant data that may exist on the plant floor or through the network. You collect that information and process it through a database that's in the cloud. And then everyone, your particular resources that you have available, the energy expertise that you're adding to your team, your specific plant energy teams, and your corporate users can all see this information at the same time across all of their facilities and compare it and manage that success relative to their corporate energy plan, whether it comes in the form of energy consumption, energy procurement, or energy utility bill analysis. All of that information is basically meant to help you address the 4 key reasons that we talked about earlier about why organizations are not making more progress against energy efficiency and sustainability. I think something happened on the screen sharing. Right? There we go. So I think that gives, it should give you a good perspective in terms of one approach to use technology to implement a structure for International Standard 50001. The next set of slides will show examples of specific sites which have implemented technology like this and an approach like this for International Standard 50001, and the system, facility, and enterprise level of results that have been experienced. The 4th case study that we'll show demonstrates the importance of understanding key performance indicators and tracking performance relative to those KPIs. So in this particular first case right here, this is an evaluation about delivering the system savings. And if you refer back to the Aberdeen Group report, which said basically you need to understand operational level, unit level savings so that you can make decisions related to that, this is a good example of that. The data points that are tracked are kilowatts per ton, kilowatts, and discharge pressure per compressor. This location is in upstate New York, so very similar to the Ontario climate. It is an ammonia refrigeration system, and the chart shows both pre and post data as it's completed by the real-time data monitoring. So this was the condition and what the data showed before any action was taken. So basically you have the high stage is compressor KPI is kilowatt hours per pound, basically ton, in the high pressure in the high stage compression. The red line is the average discharge pressure that was experienced. So before any action was taken on this particular system, we experienced a 0.052 kilowatt hours per pound, and the average discharge pressure was 127. You can also see the high variability associated with it, and this is before any discharge pressure was reset on the ammonia system. So this is what the data showed us. After the discharge pressure was reset, you saw the average discharge pressure come down to 105 pounds, CSIG, and you saw that the high stage compressor KPI dropped to 0.042 kilowatt hours per pound. Then once we sequenced the compressors, there was a further savings that could be resolved. And once you could compress that, then we dropped another 100 pounds on average. Again, if you could see the variability really evened out. And afterwards, the compressors basically had maybe higher variability, but they were sequenced better. So two strategies were implemented as a result of this data, of seeing this data. The first was that when the outside air and load allowed the pressure to be lower, the operator could make a manual change to the discharge pressure.
There seems to be a bit of an echo. Is there anyone, could you mute your speakers, perhaps? Does that seem to be better? Yeah.
And then the second action that was taken was the fact that a new compressor sequence was proposed, and an e-notice that's basically implemented as a result of the system that's in place, the real-time information system is in place, informs it when this strategy is being bypassed. So in other words, if the compressors are not sequenced as they're programmed, then an email or a text message is sent to the plant operator saying it's not being managed according to the program. As a result, $67,248 in persistent annual savings were realized with, and this is important, zero capital outlay. So that's one way about how a company is delivering system savings using the technology that we discussed, that we showed you before. So the next thing is to make sure that you're getting facility savings. Facility savings is all of the systems that are involved. And again, this is actually the same location in upstate New York. It is a food and beverage company that uses the ammonia refrigeration system. And it was actually one of their examples that the company held out as one of the most efficient plants in their entire system. And as you can see, the plant engineer was saying that they were sure that additional savings were still available, but the data itself showed them how to realize how to capture those savings by aggregating all the different system level savings and understanding how they could match that to their operations. And as a result, you can see here in a period of time from September to basically over 6 weeks, they identified far more savings that had been opportunities that were identified and then accepted in that period of time. And this was from a plant starting from a baseline where they thought they were very efficient already. So you can imagine then that the next step was basically to translate that savings at one particular site to across the entire enterprise. And if you just go back to this real quickly, you can see that these kinds of savings at one site, what if they had these kinds of savings that were available, this quantity of savings that were available at one site, what if they could take that and translate that across all their other facilities that are of a like nature? That's a tremendous amount of impact to the bottom line and a tremendous amount of savings that they were missing. So when you get to delivering enterprise-wide savings and payback, then you can begin to see that basically it's a large multi-billion-dollar company, multiple facilities throughout North America. All of the meter installation costs were financed within their monthly fee. And this is, again, the cumulative cost and savings on the left, time on the right. And you can basically see that from where they started, their cumulative cost was a fixed monthly fee, so it was a linear rise here. And the cumulative savings that they began to enjoy as things started out was basically the intersection point where it became payback was about 1.5 years. And they've been enjoying savings ever since. This is without any additional capital beyond the implementation of an enterprise-wide energy management system that capitalizes on using information like we just discussed at the system and facility level and spreading those successes across their entire enterprise. An even greater savings ramp could have been made available had they employed additional capital to increase their savings. Nevertheless, as a result of this, their energy intensity improved 4.2% in the 2 years of 2010 and 2011. Their 2012 numbers aren't quite available yet, and their greenhouse gas intensity dropped 3.2% in the same period. So this is, again, the food and beverage company, national distribution throughout North America, and you can see how it goes from system to facility to the enterprise-wide savings. And these numbers are from a public report, and this is a public company, so this is from their public sustainability report. Finally, the last case study that we'll go through is the importance of understanding the energy cost per unit. This is a different company, but again selected to show you, in environmental conditions similar to Ontario. It's basically to where they were operating prior to the implementation of an enterprise-wide system, and something that could help them understand their facility savings and their energy use in a megajoules per liter of product produced. Here's where they were. They started their data streaming and understanding how they were using their energy, started taking actions to reduce that energy use, and as a result, drove down their overall energy intensity to well below their goal and maintained it there over time. So I think the key thing with all of that is basically to illustrate the power of data, but not just data alone, data that's utilized with appropriate intelligence and expertise, and then spreading those successes across your overall enterprise. The next slide here talks basically about how do you do that? How do you take examples like that and spread them, move those ideas throughout the organization? Well, what's key is that you need to consolidate those savings ideas into a central location. You need to provide the structure for energy, water, and carbon savings analysis. You need to provide documentation for that, and then structure the communication and the approval processes with visibility across the plants and across the entire enterprise, so that you can begin to get a sense for what you're really accomplishing and the documentation that's associated with that. Now, if you remember, I indicated that I'd like you to remember that International Standards 50001 advocates a structured program, and documentation is key to that structured program. Well, it's also important to structure the overall method, and so that you can determine how to decide and act on those energy savings ideas and translate those ideas across the organization. And that's really what this type of, whether it's this or not, just how important that is to understanding that when you make a decision, or when you document something at a particular facility, you can capture those savings, realize what those savings are, have the appropriate approval processes, and record that documentation and keep it all in one central location instead of spread around the overall organization and the enterprise on people's desks, on their computer hard drives, etc. And then finally, what's critical is to communicate progress in real time so that you can continue to foster the translation of ideas into action for the entire enterprise. This is just one example of a means to do that, but what is critical is that everybody can see the progress of actual progress against particular goals that they have. So these are energy intensity KPIs up here for electric, fuel, and water. What's critical is that you understand where your savings are going to be coming from. Say it's refrigeration, or it's the process, or it's in compressed air systems on the electric side, or if it's in your maybe a hot air dryer or in your boiler systems for the thermal, and where you specifically can help to save your water end uses. That communication tool is the central element to successful enterprise energy management. But I think, of course, there's always getting from where you are to having a plan to start and sustain those results. And what's key is to assess the opportunity first that you have, assess the cost so that they're in line and you have a return on investment that matches the hurdle rate that you expect, and expect to spend something for the intelligence, either the internal resources, dedicate a resource to do that internally, or externally to have an outside resource do that for you. Enterprise-wide is really a very key element of that. As you go back to the research that talked about in the early slides there, when we talked about what prevents success in enterprise energy management, what prevents success to barriers. What's key is getting access to the information enterprise-wide so that the overall organization can take advantage of successes that are realized locally and spread those across the entire organization. One of the ways to do that is to take advantage of the technology that now exists for that, and that is using cloud-based programs that can help you communicate, track, monitor, prioritize, and aggregate opportunities into something that makes a significant impact on the bottom line. In our perspective, Ameresco advocates if you want to get the highest return on invested capital, you would control, replace, and shift. If you want to get the maximum improvement to buildings and facilities, then you would use energy savings to finance those building improvements. Whatever your whatever your particular philosophy is, it needs to be embedded and understood up front so that your energy management program can implement that particular philosophy. But then most important is to realize the savings by using expertise, either corporate expertise to support your facilities, third-party expertise to support your overall corporation, and lastly, have a 3 to 5 year horizon, because these programs take time to invest. If you go back to the enterprise-wide delivery of successes, it took 2 years for that public company to realize that a dramatic drop in their energy intensity, but it took their commitment to that program over a couple of years to begin to realize that. So I think as we look to close out today's session, I'd just like to summarize that the elements to a successful enterprise energy management program are the following. 1, you should determine if your organization has aspirations to be, or already might be, best in class. 2nd, assess whether your organization is following a model like International Standard 50001, and if not, what you can do to begin that process and the resources that are available to help you. 3rd, understand the philosophy that your organization has toward reaching its energy and sustainability goals. Is carbon reduction critical in the primary element? Perhaps using energy savings to finance other building improvements are key. Or maybe it's to maximize the return on invested capital, as we showed in the example on slide 7. Whichever it is, the philosophy needs to be reflected in the implementation of the program. 4th, determine whether your organization is implementing the best practices of best-in-class companies. Some of those best practices, as we've seen, is using unit-level energy information to make operational and production-related decisions. 5th, address the 4 key barriers that prevent progress toward energy efficiency and sustainability improvements. Those were actionable information, real-time information, energy expertise, so that you can get the capital that you need to make the changes to make the progress toward your goals. And take advantage of the resources that are available, such as the LDC monitoring and targeting programs, which subsidize the cost of implementing meters and sensors that will help you achieve the level of operational energy efficiency that are needed to be best in class. And finally, implement a structure that can translate the successes at a local level across your organization quickly. We advocate the use of the right cloud technology as one means to do that cost effectively. And it will also ensure that you have documentation and structure that's recommended by the International Standard 50001. So just real quickly, I think what's key is that you should move, act on, and communicate ideas for results throughout your organization, deliver energy and sustainability savings that will persist over time, and look for a positive impact to your bottom line and energy intensity or your goals that you're trying to reach, whether it's facility improvement or bottom line impact. So that more or less wraps up the presentation. I'd like to thank everyone for their attention and to the GTAA for this excellent venue. As you can see from this slide, Ameresco is the largest independent energy services company that provides simple but comprehensive integrated services and solutions. Please feel free to contact our office in North York. Ask for Mr. Colin Anglin if there's any additional information that we might provide. I'm available for the next few minutes to answer any questions. And Alexandra, I'll just turn it over to you to moderate that.
Perfect. Thank you so much. And I appreciate everyone's patience in a little bit of a technical glitch. We have one question, but I would encourage those who have any questions right now to type them in the chat section. If a company is cloud adverse, is your system available in a LAN version? LAN?
I guess the way that I would answer the question is that I think there's many opportunities and tools that you can use. I think LAN versions are possible. I'm not aware of any that exist out there to accomplish this particular approach, but I would say that Fortune 500 companies that have very IT restrictive environments use these technologies very successfully.
Perfect, great. And I'm just unmuting Colin. You might be participating in this Q&A session as well, so I just unmuted you. We have a question here of will the slides be available afterwards, and we have recorded the session and this will be available afterwards, so you will be getting this thereafter and the contact details as well. Are there any other questions from anyone? It was a great overview. Thank you so much, Jay. And I'm just scrolling to see if we have any other questions. And Colin, the platform is open for you as well?
Yes, I'm on the line. Thank you.
Great. Okay, so we got in another one. So how is the cost of the services determined? Is it per square foot of the building?
So the cost of the way Ameresco approaches this is we basically perform an energy assessment plan, and in that energy assessment evaluates the opportunity for energy savings that you have, and we match the cost of it to make sure that it achieves your hurdle rate. What's key to this is that the obviously if you want to meter everything or sub-meter everything, for example, you don't just want to pick up main power, main water, main gas, but you want to go into the system level. And if that already exists in your network, we can harvest that easily without any additional metering. Or if you need to install additional key meters, because it's a very important element of documenting the savings and the energy opportunity that exists, you may want to pay for that additional meter installation. But again, there are many programs out there that can help subsidize the cost of those implementations. So I guess my answer is it all depends, but you should always be expecting a reasonable return on investment for any program like this.
Great, perfect. And what is a hurdle rate?
Hurdle rate is more or less just the savings so if you're looking for a simple payback is a typical hurdle rate requirement. So if you have a simple payback requirement for your organization of, say, 3 years, then that would be the hurdle rate.
Okay, great. Do you have any other questions? That was really great, Jay. So I find whenever it was quite informative, and I guess if there's any other questions, we can always reach out to yourself or Colin. I want to thank yourself for your presentation and also through your patience throughout presenting that as well. And thank you all for coming out and listening in. Our next webinar is scheduled for March 21st and will be on transportation with Smart Commute. Thanks again and have a wonderful afternoon.
Thank you.
Thanks.